Flora is the authoring tool to help the artist to generate the influence modeling and animation. The author of the authoring tool is Junwei Huang and Haoran Wei. There are several features for our authoring tool. The first one is the toxic generation. We can input primordial models and the curve of support surface, and we can get the different type of the distribution of primordial. The color of the primordial represent the age. The red represent the old one, and the green represent the new one. The second feature is the branch generation. We can improve a set of the position of the floret and the position of the root. We can get the mesh of the branch structure. When we change the parameter, we can get a different shape of the branch. The third one is multi-floret distribution. We can improve the set of the petal and the roots, and we can get the different type of the distribution for all type of the petals in the set. Our authoring tool is based on the secret paper named Modeling Dancing Fluorescence, which is 2016 secret paper. And for our main concept of the technical approach for phyllitosis, it is extended on the red leaf paper, and it can generate the prime along the curve on the revolving support surface, which can generate spiral phyllitosis pattern based on the recursive equation. For branch generation, it is extended on the radical paper. It considers each floret as the particle, and the movement of the particle can generate the branch. We can use the equation to calculate the direction of the movement of each particle. It has three terms. The A terms represent the direction from the particle to the base. The B term represents the direction from the particle to the nearest branch, and the H term represents the previous direction. When we can weight it, we can get the new direction. For multi-floret distribution, we have two assumptions. The first one is the petal growth after prime is generated, and the second one is the petal grows in approximately planar. And the algorithm is that we can get the order of the prime creation in the phyllitosis generation, so we can get the petals growth order. And for each petal growth, it grows in a comb zone, and if there's an obstacle in the growth comb, it doesn't grow. Otherwise, it can grow. Here's our result. First is the phyllitosis pattern generator. First, we select the curve and the sphere, and we can change the time range. We click Bake. We can create the animation, and here's a different phyllitosis generation with different parameters. We can also change the size of the phyllitosis along the curve. We can change the fall off, and we can change the different type of the interpolation. We click Bake. The size of phyllitosis change. We can also change the size of the phyllitosis along the time. For right now, the phyllitosis grow along the time. We also change the interpolation and Bake. However, it has some artifacts when we change along the time, so we clamp it. It avoids the artifacts right now, and here's the result when we enable the clamp. It avoids the artifacts in the middle of the phyllitosis. The second part is multi-floret distribution. First, we have distribution of the phyllitosis and the petal. We open the GUI. It has the phyllitosis node, some rules, and the parameters. We open the node editor and drag the phyllitosis node 1 to phyllitosis node, and we drag the petal to the object. We change the parameter. We click the item, it can generate the rule. We click the button Create, it has the multi-floret distribution. And here's the different result of the different parameters. Here's an example of two rules for one multi-floret distribution. First part is branching generator. First, we select all objects of the floret and the base. We click the create branch. It can create a branch automatically.